interested in how the data offline and sync capabilities work in Oracle Mobile Cloud Service for the preserved conflict collision detection and resolution features, this episode is for you. G'day, I'm Chris Muir from the Oracle Mobile Platform team. As a quick recap, for collision detection and resolution, the preserved conflict option states when the client sends an updated object to the server, if the server detects a conflict, in this scenario the server will reject the client's update, but the client SDK will receive the chance to programmatically resolve the conflict. In doing so, the client will not only have a local copy of the updated object, but will also have a copy of the updated object from the server. So here, the programmer can merge the objects following some predefined business logic, then resubmit it back to the server. In all ways, from the server's perspective, preserved conflict is exactly the same as server wins. However, after the server detects a conflict and notifies the client, it's what the client does with the conflict and how it resolves it that is different. With this in mind, let's consider preserved conflict and the three scenarios: create, update, and delete. So, like client wins and server wins, for preserved conflict, the create scenario is exactly the same. The object is created on the client, and then when it's sent to the server, the record is created on the server too. Separately, just like server wins, on updating and saving an object on the client, assuming the object doesn't exist server side, the server will return a 404 in this case. Or if the object does exist on the server side, but no update to the server object has been made before the client's update to the server will update the server side's object. This is just the same as before. However, on the update scenario where it is discovered that the server-side object has been updated since the client synced its copy of the object and wrote its update to the server, similar to the server win scenario, the server will reject the update in this case and send a 412 error with a copy of the server's e-tag and object to the client. In this case, the save operation on the client will fail, and for the first time the mobile developer has to do something besides twiddling their thumbs. In the failed saved operation on the client will have a copy of the locally updated object and will also receive a copy of the server's updated object, and under the covers an updated e-tag too. The client programmer in this case can choose to drop the changes or programmatically merge the changes, including updating the e-tag with the server's updated e-tag and subsequently doing another update to the server to see if this change will actually pass. So that's the update scenario. Moving on to the delete scenario, again, this is mostly the same as server wins. The only exception being when the server detects a conflict and returns a 412 to the client, again, the client programmatically may handle the conflict and determine what to do. It's up to them. So there you go. With a combination of client wins, server wins, and preserved conflict, you have a range of different scenarios and options that you can use in resolving conflicts in your application. Which one you choose really depends on your application type, but as you can see, MCS is providing you the full capability or the full range of options that you can pick from. You've just got to choose one. So this is pretty powerful because there's not a lot of programming you need to do. The framework will take care of all the work for you, except for preserved conflict, but there's a little bit of programming for you to do. Okay, thanks for joining us. Hope you enjoy these videos. More videos coming very soon.